Welcome back to part 2. The video cut me off, and as I was talking to you about what this is, the period from 0 to 2 pi of the sine graph. Another part of the vocabulary I wanted to point out was on the graph, when you go from the midpoint up to the top of the graph or down to the lowest point of the graph here, we just go a unit of 1. Right? That is called the amplitude. So the amplitude, let me do that here. If you notice, the amplitude always is the distance from the midline to the maximum, the relative max and the relative min. Therefore, it's the height of the graph from the midline, and it is always, always, always positive. So that is one reason down here when we found the amplitude, you had the absolute value of A, because it is always positive when I want to know the amplitude of the graph. Now the shifting and the phase shift or the vertical shift is going to be different. Now something else I didn't talk about was the frequency. You may be asked for the frequency. The frequency are the number of cycles that you're going to have per unit. The fastest way to get the frequency is just to take the reciprocal of the period. So if the period is 2 pi, which is normal for a lot of your sine or cosine graphs, the frequency would be 1 over 2 pi. So now I would like to graph a couple examples, and we'll set these up to work. All right, this is example 1. I would first like us to graph the f function of cosine x again. So I want you to remember that cosine crosses twice, right? It's going to cross here, and it crosses at 3 pi over 2. And remember, it starts high and goes low. So we're going to start right here, and then we turn, and we're here. And then we're going to come up here at 2 pi. And then we're going to cross again, and then come back down here at 3 pi. All right, here we're going to come down here to -1. We're going to cross. We're like a little snake here, right? Now, that is my f function. So if you want, you can, graph that in one color so that you see what the f function did. Okay, that's our basic parent function here. Now, we're going to take that function, and we're going to go through these things without putting it in the calculator. Now, the first thing I notice is that right here, I'm going to shift it. I'm going to shift it by pi over 2, and it's negative, so I'm going pi over 2 to the right. I have a phase shift. So all of these critical points, I'm going to shift by pi over 2. So this point would become here, and this point would go here, and this point would go here. Everything gets shifted by by pi over 2. This point would now be here. So my graph is looking something like this. Right? It's coming up like this. This one would be here. Whoops, that one wasn't very good. Right, and that one would be here. This one would be shifted by pi over 2. That point would come here by pi over 2, because it's all going to the right by pi over 2. Now, I'm not going to put a color on that one because I still now have to shift it up 2. So now I'm going to take each of the points, and I'm going to go up 2. Take each of these points and come up 2. So if you notice, my new midline has now shifted. My midline is now at 2. Right? Now my graph is doing this number. Okay, each of these new points has shifted up 2. Here we go. That is my new g function. That is the new cosine function right here, that one. And so I would denote that. And you'll do this on your homework. You'll graph both the f function and then the g function. And I want to be able to see which is which. Now let's analyze it a little bit. Okay, so let's talk about some of the specifics of each function. The f function has an amplitude of 1. Okay, that's my absolute value of a, and it's just 1. The period is still just 2 pi. All right, our formula was 2 pi over b. You remember that? And here we don't, it's a parent function. We don't have a b. So it is just 2 pi, or b is 1 for that matter. It's right there in front of the x. My frequency is going to be 1 over 2 pi. Remember, it's 1 over the period. My phase shift. There is not a phase shift here. There's nothing with the x going on at all. So my negative c over the absolute value of b, c is 0. I'm not adding or subtracting anything here. So I have 0 over 1, which is going to give me none. Okay, so I do not have a phase shift. My vertical shift, I don't have an added or subtracted anything over here, so I don't have one of those either. Now let's talk about the g function. My amplitude here, I just have a 1 in front. So that is still 1. Absolute value of 1 is 1. My period here is still 2 pi. I still have a 1 right there. So I still have 2 pi divided by the absolute value of 1, which is still 2 pi. My frequency would still be the reciprocal of that. My phase shift, here I have a phase shift, and you can look at that right there and see that b is 1, so you don't even really need to do the negative c over b. You just know that that's going to be the negative of negative pi over 2, and that's over 1. So you just have a phase shift of pi over 2. It's going to the right. Now if you notice, remember, if you look at this, it says negative, but if I say what is the phase shift, it's positive pi over 2, and it moves to the right. The vertical shift, here we know we went 2 up. All right? So this particular graph, all right, I also want to point out that this looks like another function. Let's call it h. Well, let's put the h. Let's say h of x. It looks like I took just a sine graph and I moved it up 2. Doesn't it? Because the sine graph would have been high here at pi over 2 and crossing. It looks like I just took a sine graph and slid it up 2. That's possible. There are different ways to name the function. So if I had given you that graph and said, what is the equation, I would need to tell you, please use cosine or use sine. Otherwise, you can give me numerous answers. All right? So something else I want to show you now, I want to show you how to do this on the calculator. In the calculator, you need to, when you're graphing this, you are now in Radian mode. So remember, we were in degree mode earlier when we were doing another part of the unit. You're now in Radian mode, and you're going to use, in the zoom function, you're going to use z trig. Okay, that's in, it zooms in for the trig function is what that does. Okay, that zooms in for the trig. And that sets the window for you. It's very, very nice. Let me quickly show you what happens. So if I'm graphing, let's say my y function, first let me check my mode. I'm in Radian mode, so that's good. My y equals, let's do the cosine. I do cosine x, and then let's graph this one. That would be cosine of x minus pi over 2. So I need to do a parenthesis, pi divided by 2, and close that parenthesis again, and I'm going to add 2, add that shift on the end. Now I want you to watch what happens. I'm going to go to zoom, and I'm going to select number 7 here, zoom trig. And I want you to see what happens when it graphs. There's my cosine graph. And here is my g function graph that had been shifted. Now, if you'll notice, it automatically set my axes in radian values. It set it to be 2 pi. It set my y-axis to be by 1s. If I go to the table, however, everything is decimal. So if I go to the table and want to know what would happen, let's say at, let me ask it at pi over 2. I want it to start at pi over 2, and I want the table to change by what value? You want it to change by pi over 2 maybe. Pi over 2. Let's see what happens. Oh, it's still going to give me my graph. I'm sorry. I didn't go back to table. The table function, let me wait for it to finish. Okay. The table function now will give me values because I changed my x value to go in radians. And then my y values will adjust and will give me those points. Okay? But if you notice, I can't, you have to get used to knowing what these radians are, to knowing what is pi over 2, what is pi, 3.14, that would be 3 pi over 2, that 4.7, and then the 6.28 would be at 2 pi, and then you can see what these values are. All right, let's try another example. Okay, I'm going to, in the interest of time, I'm going to pause it and I'm going to graph the sine function, and I would like you to do the same. Remember, your sine function crosses 3 places, so you should have the sine graph. It should look very similar to mine. Now when we graph this g function, we have several things working here. The first thing I'm going to do is graph the period. Okay, that's the period. And that's going to be 2 pi divided by my b, which is now 2. So my period is now pi. That's the first thing I'm going to graph, which means I need this cycle to occur, but I need it to occur only in half the distance. So that means it needs to go up and down between only pi. I'm going to squeeze it together. Also, the second thing is there's an amplitude of 3, right? That's my amplitude of 3. That's the second thing I'm going to do. Absolute value of 3 equals 3. So I'm not only going to squeeze it all in between 0 and pi, but I'm going to increase it to go up to 3 and down to 3. So this is where it's going to cross. And it's going to peak here, and it's going to peak here. But we're not going to peak here, we're going to peak at 3. So we're going to come all the way up to 3, and we're going to come down to 3. So this would be 1 period, just right in there. You see what we did? So we came down here. And we're going to come up here, all within that 1 area. We've done 1 period. So now I've done the amplitude, I've done the period, and now I'm going to have to do the phase shift. And I have 30 seconds left, so we're not going to be able to totally finish this. But I do want you to notice that here, if I'm doing the phase shift, that's going to be the next thing I do. And I'll just write this down, but we'll have to do it in class. The phase shift is going to be the third thing I do, and I'm going to take that c, which is pi over 2, and I'm going to divide it by 2. We'll pick up here in class. Thank you.